A professor is never late. Nor is he early. He arrives precisely when he means to. Good morning, Fancy Meat Computers. How are you? I'd just like to point out that I am not, in fact, late, despite certain claims by certain people in the chat. Jeez. Jeezen. So, anyway. How are y'all this morning, this fine November morning? Hopefully you're doing okay. Everybody getting destroyed by, round 2 of midterm season? Is it round 2 of midterm season? Or is it, like, in-betweeny bits? It is very bright outside. It looks like a lovely day. Like a crisp autumn morn. But, you know, not a cloud in the sky. Perfect day for raking leaves. Vibin'. How are you doing? I'm doing good. I was, Round 2 starts next week? Well, my condolences. Yeah, I'm doing pretty well. I was, you know, things have been a bit crazy lately. You know, the work has been, there's been, like, a lot of unexpected stuff, so, you know, just takes time, you know? But, you know, we're getting through it. I think I'm up to, like, on the order of 40-ish academic dishonesty charges at this point. It's like, it's a lot, you know, because you have to, it basically ruins my entire Friday for getting anything done. But, you know, and I used to really like Fridays because I could get a lot of work done on a Friday because, like, nobody's emailing you typically on a Friday, you know? It's like nobody's bothering me. I can actually get some work done, but, you know. Anyway. So. I said on the order of 4. I think the actual number is like 38, but I'm sure we'll hit 42 by the end of it. Can we get a domain in the assignment questions so we know how optimized our code needs to be? Talk to Mark about it. Do we get any essays in the comp sci program? I think everybody has to take 3IO3, which is it's third year course, and it's like communication skills for STEM people type course type thing. It's yeah, I think they jam all of the essay writing into like one course in third year. Generally speaking, if you liked writing essays, you should have majored in like literally anything else. I wish we could get some input constraints. Most of my questions are about those. I already hate that course. Yeah. Don't worry, it's dead easy. Basically, if you passed, like, grade 10 English, I think you'll be fine. Hmm. Yeah. You took this program because you didn't want to write essays? There you go. And you chose the right program. Mm. So someone asked me what happens when someone gets charged for academic dishonesty, which I believe I said this at the beginning of the term, but I guess it bears repeating, just if people are just kind of curious. So, at McMaster, we have a system of escalating consequences. Essentially, I have to when I have a suspicion of academic dishonesty, I need to conduct an investigation, which is to say, I need to look at the thing. That investigation will lead to my well, actually, Manav has been handling a lot of it for me. He's a he's a he's a trooper. Send him your love if you're in his tutorial, because he's been having way too much work to do lately. But he sends out an email and he tries to get a meeting arranged between myself and the offender, and I've been doing those on Fridays. But once the meeting happens, it's like, it's kind of like I think you cheated. It's like, well, no, I didn't. It's like, okay, but explain how this isn't cheating. And it's like, they have an opportunity to explain why it's not cheating, and if it's a sufficiently good explanation, then I'll drop it. It's most of the time not a sufficiently good explanation, because I don't like. It's a very time consuming process, and I don't go after people unless I'm pretty sure, So what happens from there is if the result of the meeting is that I am not sufficiently unconvinced that cheating occurred, then I file some paperwork with the academic integrity office, or Manav does on my behalf, requesting a records review to see if there are any previous instances of cheating on the student's record. And because you have to wait till that point in the process so that previous instances of academic dishonesty doesn't prejudice the outcome of the investigation, right? So, lol, is that ever awkward? Ha! You're telling me! Yeah, it's pretty awkward. So if it comes back as this person has no prior offenses, then the thing that is done is you get a 0 on that, whatever it was. We've had some instances of people cheating on multiple things, which I think, technically speaking, if you cheat on multiple things, it should just be a straight F. But we've been going with slightly more lenient. You get 0 on all of the things you cheated on. And so that's the first offense. And a record of the incident is held onto by the Academic Integrity Office in perpetuity. Because if there's ever an investigation in the future, it'll no longer be a first offense, right? So that's for a first offense. Fortunately, the overwhelming majority of cases are first offenses. If it's a second offense, however, things get a lot more serious. Essentially, and I've never actually gone through the procedure of a second offense myself, although it turns out I will be doing that this semester. Ordinarily, the consequence for a second offense is outright failure of the course with transcript notation. Like something that says, you got an F for academic dishonesty, and that's in your transcript, and you can't expunge it. An employer is going to see it. So, very, very serious business. So, because it's that serious, you need an arbitrator that's appointed by the university, and there's a meeting between myself, the arbitrator, and the student, and essentially it's modeled after a common law court system, actually, where like both parties get an opening statement. You can call witnesses in. The witnesses are only allowed to be in the room while they're giving testimony. The other, whoever is the other person who didn't call the witness gets to cross-examine the witness. There are rules about evidentiary proceedings. Like you have to, there's like a discovery phase where any documentation I have has to be shared with the student. Any documentation the student has to be shared with me, so that a case can be presented properly and fairly. And the standard of evidence in these proceedings is what's it called again? Preponderance of evidence. So if you know anything about the legal system, there are essentially two standards of evidence that are applied in the legal system. One is preponderance of evidence, which is to say, well, I find it to be highly probable that you did it. And the other one, which is the one that's used in criminal proceedings typically, is beyond a reasonable doubt. Anybody who's watched Law and Order will know all of this, but so the evidentiary standard in civil proceedings is less burdensome than in criminal proceedings. In criminal proceedings, you have to prove beyond any reasonable doubt that the person did it. That's the standard of evidence. Whereas in civil proceedings, the standard of evidence is preponderance of evidence, which is, well, looking at all of this evidence, I'm pretty sure that you did it. And, these are like, ordinarily civil cases are handled by individual judges and not juries, right? And that's sort of the standard of evidence that the judge uses. But yeah, so, and I believe the arbitration mechanism kicks in for a third or higher offense as well. So third or higher offense is just suspension or expulsion. On a balance of probabilities, I think it's called. Yeah, it's they probably have different names for it in different judicial systems. Like the American system probably calls it something slightly different, or like I might be using the American terminology because I watched so much Judge Judy as a kid. But yeah, so it's a whole thing. And I don't get paid any extra for it, so I'm doing it out of the goodness of my heart. But yeah, technically this is part of my duty as a professor. But yeah, so it's pretty. Once it gets past the first one, which is kind of like a warning, then shit starts getting real very quickly. But yeah, how can you prove beyond a reasonable doubt? Like a video of the person cheating or witnesses? Yeah, so, well, again, it's preponderance of evidence, not beyond a reasonable doubt. That's the standard of evidence for these types of proceedings. But, there are some pretty incontrovertible, you can have some pretty incontrovertible evidence of cheating. Like two people submitting the same essay, that's if it's the same essay word for word, it's like if you had that plus if you, for example, had copies of communication that proved collusion, I would say that would be beyond any reasonable doubt. For my standard of evidence, normally I kind of take the view of it that, if I have so close a correspondence between two students' work that, I can't tell them apart, and, in coding, this is usually, either direct copying or, copying with slight renaming of variables is kind of a common one. I kind of my approach to it is I don't need to demonstrate I don't need to demonstrate a conspiracy because I have the evidence of the outcome of the conspiracy, right? I don't need to I don't need to have the emails. I don't need to have the chat logs, because I have the outcome of those, and the outcome is in and of itself sufficient evidence that the crime occurred, right? It's like, well, I didn't commit murder. Well, there's a dead body in a closet that can only be opened by you. So, that's kind of the level of it. Yeah. So, has there ever been a case where the person was able to convince you that they didn't do it? They didn't do academic dishonesty. Well, there have been one or two. And, sometimes it's like, I'm still pretty convinced that you did it, but that's a good enough excuse. This seems like a lot of hassle compared to taking the L on the assignment. Yeah, well, that's the thing, right? Is like, with academic dishonesty, I always tell, people, well, I don't always tell people. If people seem like sufficiently contrite during the meeting, and I feel like, if I feel disposed towards pity towards them in their situation that they found themselves in, I say, this, it is better to get a 0 than to cheat. Because if you cheat, we will catch you, and if you get caught enough times, you're out of here, But, yeah. But here's the thing, right? In order for people to be in the mindset, I don't know this problem, I'll just tank it and take the 0, they need to think that there's a reasonably high probability of conviction, right? If people think they can get away with it, then they'll try. And, the process, I don't know what it is about this semester, but, normally, I only have, 5 or 6 incidences, over the entirety of a semester, but, this semester, for whatever reason, I'm getting, between 10 and 20 hits per assessment, and a lot of them are ending up to be repeats as well. But yeah, so I'm telling all of you this, so you don't cheat ever in your lives. Don't cheat. Don't do it. Don't do it. I'll find you. Even if you're not in my class, I'll find you. So don't do it. Maybe because it's mostly online. Yeah, see, so I have a counter-argument to that, actually. Because last year was online, and I had, no academic dishonesty. And we were very much running the exact same checks. A certain amount of, the introductory checks that we run are automated, right? We use MOS, and which it stands for Measure of Software Similarity. It's a software tool that was done, I think, at Cambridge or Princeton or one of these universities. But anyway, but yeah, I had no cheating last year, and this year I have all the cheating. I don't know what it is, but it's really killing my productivity. Yeah. Okay, this sounds like a very weird question, but if someone accidentally leaks their code or something, can they tell you something like that? Yeah, so be sure not to accidentally do it, right? But yeah, if something happens where somebody steals your laptop or something, I don't know, let me know. But yeah. Incidents as in they cheated, or incidents as in you needed to investigate. Again, I don't really investigate unless I'm like 99% sure. But yeah, incidents as in I needed to investigate. But since it's code, shouldn't we expect everyone's code to look similar? See, that's an interesting thing, right? So consider the factors at play, right? When you write a program that's of like, let's say it's a decently sized program, you know, like if it's like a 4-line solution, I wouldn't go after someone for having two solutions that are the same, because like for 4 lines, you know, there are only going to be so many possible ways of composing those 4 lines. But like every line that you add to the solution multiplies, like think of it combinatorially, right? It multiplies the space of possible solutions to that problem. So you'd be surprised, you know? Like everybody uses their logic just slightly different from everybody else. Everybody uses slightly different variable names. Everybody has a slightly different approach to the problem. Like people sometimes think that code, like when you write code, your code ends up looking like everybody else's code. But that's really not the case, particularly when the question is more of an open-ended kind of type of question. And just between you, me, and the fence posts, the open-ended questions are generally the ones that get cheated on because they're more difficult, right? So if the question is easy and the person knows how to do it, they won't cheat. But if it's hard and, you know, maybe slightly ambiguously worded, that'll be an opportunity that'll bring out the cheaters. Stanford, yes, it's Stanford. Thank you. People said that last year some courses were buck easy because the online system was fairly new. Has anyone been kicked out for cheating yet? Well, I can't discuss the details of any currently ongoing investigations, but let's just say I anticipate that there will be some second offenses in the set of sort of investigate. My prediction is that there will be some second offenses that result from the investigations currently ongoing, and yeah, those people will be kicked out of the course if the arbitrator finds in my favor. I feel like beginner coders would have somewhat similar parts to their code versus experienced coders. Actually, it's the reverse. This is interesting, right? While you're figuring out how to code, you're more likely to do, like, divergent things. It's once you become an expert at coding that your code starts to sort of... it's like in martial arts, they say something like there are 2,000 novices but 3 masters, you know? And that's sort of an expression of that. It's like every beginner starts off with a different style, and they sort of snap off the redundancies and streamline their process over time. And as they sort of break off redundancies and streamline, their code eventually more and more resembles that of a master coder, right? And as you get to the master code, that level, that's where you are. But yeah. I thought law class was at 12:30. Yeah, sorry. I guess we've been talking about this for a while, but yeah. Yeah. Sorry, yeah, we'll talk about code. Yeah. Yeah, like, yeah, another way to phrase that is, like, there are 100 million suboptimal solutions to a problem, but 3 optimal ones, right? Just getting kind of curious the whole process, but when a person is being investigated, are they notified? Yeah, they're notified. Yeah, for sure. Okay. So let's keep moving with the material then. So, we were talking about classes. So, we went through our point example. We talked about inheritance. Now let's explore some of the finer points. So let's imagine that we have our colored point example, right? Colored point inherits from point. Point inherits from the most general thing in Python, which is object. You can tell the type of an object by using the type function. So if you call point, if you call type on a point, it'll give you point. If you call point on a colored point, or sorry, if you call type on a colored point, you get colored point, and you can use that like in a equality comparison to be able to determine the type of a of an input to an argument, an argument to a function, for example. Like someone was saying yesterday in class, wouldn't it be more intelligent, for example, during the distance operation, to check to see that other is a point before we proceed calculating distance over it? Because otherwise we would hit an error. And the answer is yes, absolutely. And the way that you would do that, possibly, is using type. However, here's the problem, right? It doesn't take inheritance into account. So if, for example, we have Q, which is a colored point, and we try comparing the type of it to point, which it, technically speaking, you might expect this to be the case because point has all of the things, or Q has all of the things in point. It inherits from point. However, it is not a point. It's a colored point. So we have a different method for that. It's called isInstance. So we can assert isInstance, or, you don't have to use it in an assert statement. You could also use it in an if statement. But isInstance will tell you whether or not the object is a particular class, or if that class is one of any of the classes that this class inherits from. Does inheriting from objects give you any special methods or properties? Only those previously defined. So, inheriting from object. Yeah, it's everything. So, all of your default versions of equality and string, there'll be a default constructor in there. Basically, all of your magic methods will have corresponding definitions inside of object, which you are overriding when you define your class. So yeah, there are lots of things inherited from object, but generally speaking, we kind of don't really think of them. We like the stuff that's inherited from object. We kind of think of being artifacts of Python itself, because there is no object that doesn't inherit from object, right? There's no class that doesn't inherit from object. It's the base class. So everything has these things, the way that object defines them. Good. So, what is the difference between type and isInstance? Well, I just explained it. Type will only give you the name of the class, like the top-level class, whereas isInstance allows you to compare between any class name and will return true if the object is if it is directly the class that you're referencing, or if it inherits from the class that you're referencing. Both will come out true with isInstance. So, let's talk about multiple inheritance. So, inheritance is great, although most of the time when people think they want inheritance, what they actually want is composition. But, I actually don't think we have any slides on composition in here, but composition is really easy to understand. It's just like, imagine you had a rectangle, right? A rectangle has 4 points. So it's not a new type of point. It contains 4 other objects. right? That's composition, and that's a perfectly valid scheme, right? I would argue, and I've read stuff that would suggest most of the time when people think they want inheritance, what they actually want is composition. But it's a different tool for a different job. So 2 questions. What if you add other definitions to colored point? Is instance still work? Yeah. Yep. It would. I assume by other definitions you mean like more methods being declared inside of colored point, or more attributes added to it. Could we create our own error classes, and how would we do that? If you watch back a couple of lectures ago, I did that explicitly. So you should watch previous lectures. So multiple inheritance. You'll notice that, like, colored point doesn't just inherit from one thing, right? It inherits from point, and it inherits from object, because point, like, it gets all of the stuff in object sort of via transitivity, right? It's like point has all the stuff in object, colored point has everything in point, so it also has everything in object. So that's like linear inheritance, but you can also have branching inheritance. So let's imagine, just for a moment, we want to abstract the property of color, right? So we say to ourselves, as we're developing, this system of geometry, we don't necessarily want to apply the color property explicitly and only to points, right? It is possible for many different things to have a it's like a grandchild. Yes! It's possible that you could have many different things that could want to have color as a property, right? Points, figures, lines, just to extend the geometric metaphor, any of these things could want to use color. So, what we can do is we can extract the color, like the stuff that makes a colored point, and pop it into its own class, which is what we've done here. We now have a point class, and we have a color class. From the two of them, we can compose a colored point class. So you can see, anything that has to do with point or color, we are making use of the definitions of the methods contained in the point and color classes. So we don't actually, there's nothing really contained in here that's not explicable in terms of other methods in other classes, except for, this concatenation with a comma. That's the only thing that's unique here. And, so that means that the color class is now liberated from the confines of the colored point class and so if we wanted to do a line class, or we wanted to do a rectangle class, we could just have it inherit from color as well, and bam, it has a color. The only tricky bit is hooking everything up, right? You have to explicitly extend your definition of, for example, equality to include the equality definitions for both point and color. So even when we inherit, we have to do the self-constructor again. You don't have to, but yeah. I believe it's legal for you to leave out the constructor, but if you want to extend the constructor with more parameters that account for the new information that you're providing, then you would have to redo the constructor, yes. Good. So, color only serves as a base class for inheritance. One would not think to create an object of a class that was, one would not think that color would be a thing that exists sort of on its own, which is true. Superfunction go burr. Yep. Uh, so the so think about color, right? Think about color as a sort of concept. You don't really get color without an object, right? It's like color, like any color that you care to name is an adjective and not a noun. Color isn't real, confirmed. Yeah. Right, like color is an adjective, not a noun. Even if it's used as a noun, like say in one of my son's one of my son's children's books, it's like, this is the color green, and they just have a green square. It's like, okay, but the ink is green, right? So we can do that. We can make adjectives with classes. We call them abstract classes. The only purpose of an abstract class is to serve as a base for inheritance. Sort of pragmatically speaking, in terms of programming, you would never expect an abstract class to actually be instantiated. Like, it's possible, but it's not the reason you built it, right? So if you don't redefine EQ for colored point, would it just use the default definition of EQ? Yeah, I think so. I think it would go back to, let's see, can I copy this? Can I copy this effectively? I hate that coloration scheme. It's so hard to read. That's better. So let's actually do it. Let's say class color inherits from object def init self color not whatever self dot color equals color, and then the darken method, def darken. I'm going to do this with string. I'm going to do this with strings. There we go. Just, give it something. So if we refactor this to inherit from both point and color, there we go. We can say, oh, we'll just leave that the way it is. We don't need this anymore. And let's just see what the default behavior is by commenting this out. So, that's interesting. So, I haven't specified a string conversion method here. I've got one in color, and I've got one in point. And what it seems to be doing is it seems to be pulling the definition from the first class in the list of inherited classes. So it seems to be using the definitions from point, which is interesting. That's not what I would have expected. Wait, shouldn't that be color 0? Yes, that's true. Although this constructor was never, it wasn't a problem because I wasn't using it, because I was kind of I was instantiating it here and not making reference to this constructor, so it doesn't really matter. But yeah, or it didn't matter in this case, but it would matter in other cases. But yeah. So do we say that all base classes are abstract classes? No, because in the case of point, you could definitely see yourself using a point sans color, right? That's something that you like. That's a noun, so you could expect to see it actually used, right? So we made a class that only describes color, and we can now embed color in other classes using inheritance. Yes, very good. Some kids' books are so ambiguous and non-specific. You're telling me. Wait, shouldn't that be color? Yeah. Does Python not have multi-line commenting? Technically, no. Technically, if you want to do a multi-line comment, you have to do a docstring. Docstrings are the way that you do multi-line comments in Python, but they serve as the documentation feature as well. So you wouldn't do like a mid-line comment with docstring. That wouldn't make sense to me. Like, I don't even think that would be syntactically valid, but I can try it. What if I just comment this out? Can I even do that? Is this still syntactically valid? Nope. Invalid syntax. Yeah, so they don't really work. Multi-line comments they're not really hugely good in Python. Wait, Python allows you to inherit more than one class. My Java brain can't comprehend. Yes. How is composition different from multiple inheritance? Well, I'll just whip up a quick example for you. So let's say we had a class, and we wanted to make a class triangle, right? We would not inherit from point. What we would do, and I'll just skip like the bit where we initialize it with actual arguments. But what you would do is you'd do like self.a is equal to point with, 0, 0. Self.b is equal to point 0, 1, and self.c is equal to point 1, 0, right? So, and we could fill this in with more methods if we wanted to. Like, we could calculate the area, for example, if we wanted to do some geometric functions with it. But yeah, so this is an example of composition. So this class contains 3 objects of the point class, but it does not inherit from the point class because it is not a point, right? A triangle and a point are a different thing. A triangle is composed of points, but it is not itself a point. So we can say all abstract classes are base classes, but not all base classes are abstract classes. Yes! Abstract classes are a subset of base classes. Why do you need self.color in colored point if it inherits from color? I mean, you don't really. I mean, I could just use like the initializer from color. Color.init self and color. Like, I could just do that, and that would work too. Did you know that if you highlight a block of comments and hit Control-K, comments the block? I don't enter keyboard shortcuts given to me in chat anymore because of the Minecraft incident. But usually there's something in the right-click menu. Change case, no. Options. Tools, maybe? No? Okay. It depends on your editor. It's like an editor thing. I forget what it is, but yeah. Is the example of multiple inheritance in the slide a composition too? No, this one is multiple inheritance. This one is multiple inheritance. So, the difference is, right? Under multiple inheritance, if you instantiate colored point, you get one object, a colored point. Under composition, if you instantiate a triangle, you get a triangle which contains 3 instantiated objects colored like points A, B, and C. Yeah. Does that triangle class allow you to define a triangle other than the one given? Yeah, absolutely. Good question. So, yeah, if, for example, I said t is equal to triangle, and I said, t dot a dot x is equal to 4, t dot a dot y is equal to 7, you can access... So this is an interesting one, right? So once you start talking about composition, you can also chain together access of things through dot notation. But yeah. What's the point dot init do in this example? It initializes all of the things that are contained in the point class, right? So when you initialize the colored point, right? When we define our constructor for the colored point, what it's doing is it's overriding the constructor of the first provided inherited class, right? So if you don't have this in here, it's going to default to whatever is provided by point, right? But if you define anything here, that overrides it. So how do you access the constructor for the point class itself? You do it by saying point.init self, and then you give it the parameters. So you can access the constructor for the thing you're inheriting from that way. Yeah. Good. Abstract classes. Oh man, we do not have enough time to do birthday calendar, unfortunately. So next time in class, we will do a bunch of examples, slightly more expanded examples than what we've done so far. Are there any further questions? Are there any further questions from the class on the subject of inheritance and composition and all the rest of it? I didn't actually run this to make sure that it type checks. It works. Is memoization possible only with recursion? If yes, then how is it possible to optimize loops again? That's an interesting question. So you have to sort of bring into your mind the position in which memoization is most profitable. Like, memoization, as we described it with the Fibonacci sequence, this is one particular example of a much more general technique in computing called caching, right? So the general idea with caching is that you set aside some memory, you store calculated results in that memory, and then instead of needing to recalculate those results. We just pick the appropriate value out of the cache, and, you know, to some degree all memory is caching, but, you know, a cache is kind of a more organized way of doing that. That's, like, tied to a specific function or something. Like, on, for example, in some, on some computer systems, like, trigonometric functions can be expensive to compute, especially if you need a lot of them. And, you know, there are applications where you need a lot of trigonometry, like video games need a lot of trigonometry, typically, because it's like, you know, you're trying to calculate vectors in three-dimensional space and that sort of thing. So, what a lot of systems will do is they will, anytime sine is calculated with a particular value, if it's not in the cache, they'll do the calculation and then place the result of the calculation in the cache and then pull it out as needed. So if you're talking about, like, yeah, so basically what we're talking about is dynamic programming, which is an advanced technique that you probably won't see until second year at the minimum. Probably you won't see it in depth until third year. I know I covered it in grad school. So dynamic programming, that's kind of the idea of dynamic programming. But, like, if you're applying it to a specific problem, like, say, a function, you get the most bang for your buck if your problem is already recursively defined, particularly if it's recursive with branching choices, right? Or branching things that need to be computed. So, if we think back to the make change example, right? With the make change example, we had coin choices that we needed to make in order to find the optimal solution, because as we discussed on a slide in that lecture, the solution that we came up with, which was the greedy algorithm solution, is suboptimal because it won't return the lowest number of coins each time, or in all cases, right? It'll perform consistently. It's just some cases will bugger it up. So, what you could do is you could memoize that algorithm on, like, because it's a matroid, right? You make one decision about the problem, and that sort of shrinks the problem into the same problem, but just a bit smaller, right? You could cache results on, like, you know, I give the function these inputs, I get that output. You could save those intermediate results, because if you had to, like, if you did a backtracking algorithm to find the best possible outcome for that algorithm, you would be able to make use of those intermediate results that you kept, and that's kind of the same thing as memoization. I hate the word memoize. Yeah, me too. I would be inclined to just call it caching, but you know. So yeah, so to that extent, it doesn't really matter if you're using a loop or a recursion in order to solve the make change problem. Like, I remember I remember the way that we solved that problem was using a loop. However, if you were to do an algorithm that used backtracking, that loop would, like, it wouldn't be as simple, right? The reason we did the greedy algorithm is because it's straightforward, right? It does sound like a kid trying to say memorize. Or you could do, like, the, what do they call that? Like a glottal stop? Like in most languages when they have the letter R. Memorize. You sort of click the tongue. Anyway, apparently, the way that English and English people pronounce the letter R is, like somewhat unique to them. But anyway, what was I talking about? Memoization. Yes. So to that extent, if you had a sufficiently complicated algorithm with loops, you would definitely still be able to make use of a memoization scheme or a caching scheme. Because fundamentally, like from a fundamental level, recursion and loops are interchangeable, right? However, it's, something is sometimes it's much easier to say something in a recursion than in a loop, in which case you should use recursion to do it. But yeah, that's essentially it. Hopefully that answers your question. That was a really good question. Thank you. Any other questions? Do you have any tips to make more efficient programs? So far, my answers to the assignments feel really roundabout. So, it's really just practice, you know? It's kind of like if you want to improve quickly, you should write as much code as possible. However, a certain amount of, like, it's gotta, like, normally when people ask me how to improve their programming code, I tell them go try a project, like go take out a project, like go start a project and see where that takes you. But in this particular case, I think I'm going to suggest continuing to do school. As you take more courses, you're going to learn to think more and more rigorously about algorithms. That's the whole point of this degree program, is that you're going to learn to think more and more rigorously about algorithms. The more rigorously you think about algorithms, the easier it will be for you to write them, and the less sort of extra fluff you'll have in them, right? It's also a matter of like really getting to know the language that you're working in. Like for example, when we do C next semester in 1xC3, again, if I get the course, still in the applications phase, when we do C, it's going to be like the first thing that you're going to do probably is you're going to be like, okay, so how would I do this in Python? Let me translate from Python into C. And it's like, that'll get you about halfway through the course. But at a certain point, you have to learn the stuff that's sort of unique and idiosyncratic to C, right? And actually, I think that learning C will make you a better programmer in every other language. It's like, I think, I also think that about Haskell. Like, I was like a level, 6 programmer, and then I, properly learned how to program in Haskell, and I suddenly jumped from being a level 6 programmer to being like a level 11 programmer in every other language too, because what Haskell really does is it trains you to think correctly. That's the reason you should be learning Haskell, is to learn how to think about problems correctly. Because if you learn how to program in Haskell, it's different enough that your bad habits from other programming languages won't transfer. it's got a strict enough type checker that it'll break you of some bad habits. And in order to program it, I'm sure you guys have, who are in 1JC3 have noticed this by now. In order to program anything in Haskell, you need to have thought the algorithm through completely before writing it down, right? Or at the very least, you need to co-compose the algorithm with the compiler. But what the compiler is actually doing is it's training you to think about functions correctly. So that's like, once you've realized that you don't actually need that much state to program, you will start using less state to program. Like, you won't rely so much on declaring like a million variables, right? It's like, it'll be like, well, I can write this function without even declaring any variables at all. Look at that. And then you just do it. And that's actually better programming because, believe it or not, a lot of the errors that arise in programming are because of state. This is like a secret that you don't learn until third year. But like a great number of bugs in programs have to do specifically with the fact that you're holding state. And you can often solve such bugs by holding less or no state in any particular function. But yeah. I agree. I like Haskell. Feels like I'm improving. Yeah, like, I really, like, I know it's, like, kind of a controversial choice to, like, introduce you to Haskell in first year, but, like, and, like, this early, you know, because arguably you shouldn't really be exposed to Haskell if you've got, like, absolutely no effing clue about programming whatsoever. It'll just confuse your pants off. However, it really, like, what they're really trying to do is they're trying to get you thinking rigorously before you've developed the bad habits, right? Yeah. Haskell actually makes you think about your algorithms more thoroughly and just improve your programming mindset. Yeah, like I learned how to program in Haskell, and then it was like, wow, I'm a much better programmer now. Because, like, you know, kind of one of the things that I was doing immediately after I programmed Haskell is, like, I also I also picked up Unity and, like, C#, and I was noticing that, like, when I was writing a, like, an update function for a game object, it was like, yeah, okay, but how can I have the game object interact with its own state as little as possible? And that, like, the less it interacts with its own state, the more likely it is to work. But yeah. So far, Haskell assignments, I kind of just turn my brain off and follow recursive patterns. I mean, that's kind of the beauty of Haskell programming, though. It's not turning your brain off, you're just using your existing mathematical knowledge. You know? Yeah. Yeah, but like tail recursion is kind of addictive. Once you learn to, like, deal with lists as tail recursion, you'll find yourself doing it in languages that aren't Haskell, I guarantee you. Sometimes I can write recursive functions in Haskell, but I have no idea how to write them in Python, even if the questions are similar. Yeah, I find the biggest barrier is, like, the pattern matching. I think, like, Haskell's pattern matching tool is extremely powerful, and it doesn't really have an analog in Python. Like, you would have to explicitly, like, pull apart the pattern matching mechanism and, like, re-implement it in Python, and that would be, I think, the first step. But yeah, like, yeah. Anyway, Anyway, I should probably do other stuff. Thank you very much, everybody, for coming to class. Yeah, like, as much as Haskell is a pain in the ass to learn, it's like, make no bones about it, it is a super good language. If anybody is interested, there's a very good computer file video about the origin of Haskell. You should go look it up. Maybe I'll post it to my feed. That's a thing I'm doing with my feed now. It's like memes and reposting computer file videos. Take her easy, folks. Don't do anything I wouldn't do.